In this video, I am going to be talking about the following topics. First, I will discuss about static and dynamic memory. Then I will talk dynamic memory allocation. Then dynamic memory deallocation. Then after that, I will talk how dynamic memory allocation and deallocation can be implemented or realized in a class. And I will touch upon memory issues, particularly memory leak and insufficient memory. Before I explain the concepts through coding, let me briefly explain stack, heap, and code memory. When a program is loaded by operating system into the RAM for its execution, the program gets some memory, and that memory is organized into different segments. It can be a stack segment, it is can be heap segment and code segment. Essentially, the memory is divided into stack, heap, and code segment. A stack segment gets the memory space allocated, in other words, memory space allocated for the variables that are defined inside a function, or the objects defined inside the function, or the arrays defined inside the function. Arrays of fixed length defined inside the function, they get space in this stack segment. The memory required for an object, variable, or array for allocated in a stack segment is determined by the compiler during the process of compilation, and once it is determined, it remains fixed. When the memory is to be allocated, when program is executing, sometimes we may need to our program to get extra memory based on its execution requirement. In that case, memory can be allocated in the heap, and allocation of memory in the heap is called dynamic memory allocation. Memory allocation in heap takes place in runtime, and the process of allocating memory in heap is called dynamic memory allocation. Sometimes this memory heap is also called free store memory allocation. In contrast, the memory allocated by the compiler during the compilation is called static memory allocation. It is allocated during compilation, and the memory is fixed. Now, I am going to be using this editor to explain the concepts. This is a function, main function, and inside the main function, if you define a variable int x or equals to 5, double y equals to 3.6, int x IARR 25, and int pointer, array of pointer, all these variables are within the function scope. It could be also within another scope of another function, which is going to be called by the main function. Let's say, right, I would have the variables defined inside the function, like this. So all these variables, the memory required for these variables is determined during the compilation time. Therefore, this is called static memory. Once it is determined, the amount of memory needed for these variables does not change. Now I'm going to explain dynamic memory. These are called static memory. In other words, you should understand it this way. These variables, these data items, get their memory allocated as a static memory. The way of allocating dynamic memory is you have to use the keyword called new in C++. In C, there is a different function to be used. You use the new keyword, and if you want to allocate a dynamic memory to store, for example, this 5 as an integer value, in that case, you specify the type new followed by type. Then this statement will allocate a dynamic memory. What this statement does is it essentially allocates, let me type this statement here. Now this new int statement will essentially allocate a dynamic memory in this heap. Let me use this space. For example, this is a memory allocated by this statement, right? So now this is memory allocated, but it is in the heap. There is no way, it doesn't have any name, no identifier, there is no way to access this memory. To access this memory, you need to either have identifier to refer to the memory space, like in this x equals to 5, like in this x equals to 5, or you need to have something that can point to this memory space. And the way to access this memory is to use the pointer. And good thing is that this expression, you can call this as an expression. This expression returns a pointer to the memory space. This is a memory space allocated, and it returns the address of this memory space. And you can make an integer to point to this memory space. So let me go back to, as you know, this expression evaluates to an address. So that address can be copied to a pointer, right? I can create an integer pointer, and I can make this pointer point to this address. Now I have something to refer to that address or to access to that address by using this pointer. Like if I have a pointer to if IPTR was set to address of x, then you would be able to use IPTR to write data into the memory space allocated for x, or to read the data from the memory space allocated for x. Similarly, in this case, IPTR is set to the address of this dynamic memory. Therefore, you can use this IPTR to write data into that memory space or to read the data from that memory space. Let me do that. I want to write data. The way of accessing that memory is dereferencing the pointer, and I want to write data, let's say 21, into that memory space, right? So this statement should write 21 into that space, and I want to read and display this data. Right, this statement should read, this is the expression which should evaluate to the data 21 to be accessed, and it should display value 21 to the output stream. I'm going to compile this code and see the output. As you can see in the output screen, 21 was the value copied to this allocated memory space, and it is displayed through the pointer. So this is the dynamic memory allocation, and this is the use of pointer to access to that dynamically allocated memory space, right? Again, this is the dynamic memory allocation, and the use of pointer to access that dynamically allocated memory space. Now what this code did was, what this line did was, it allocated the memory space and copied this address to a pointer. So this pointer is essentially pointing to this memory space, dynamic memory space, right? Once it is pointing and you use that pointer to access that dynamic memory space, and at some point of time, if you feel that that dynamic memory space which was allocated is no longer needed within the throughout the execution of the program, it can happen in the middle of the execution, it can happen at the end of the execution. If you feel that it is not needed, then you must release it. If you don't release it, and this IPTR is a pointer which is static memory, which gets the memory in the static space. If it goes out of scope and this identifier no longer exists, now you don't have anything. Like in this case, the situation becomes like the previous case. You don't have anything, any way to accessing this memory. So this memory remains occupied. And if you have a large number of such memory occupied, then available memory space in the heap becomes insufficient, right? So performance of your program can go down. Again, let me explain this one more time. If you have IPTR, dynamic memory space allocated, then you need to release that. Otherwise, there is something called memory leak issue, memory leak problem that takes place. Right? If it is not deallocated, memory leak happens, so you need to deallocate. The way of deallocating is through the use of the keyword called delete, right? You use keyword delete followed by the name of the pointer. This is a statement for deallocating the memory that was allocated in this place. And this is an example of allocating dynamic memory to store one data item of integer type and for deallocating that. And allocation and deallocation for other types, for example, for double type, you need to change this keyword to double. It goes that way. Now I'm going to talk about a little bit more complicated thing. For example, let me switch back to the another screen. I want to have a dynamic memory space allocated to store not only one integer value, but I want to store an array. Let's say array of 5 integer values or array of 10 integer values, right? For that, I need to allocate the dynamic memory. Instead of this one data item allocation, I need to have a multiple data item allocation, or allocation for multiple data items, or I need to allocate memory which is sufficient to hold multiple data items, right? The way of doing that is something like this. I give the name IARRPTR, array pointer, new int, then you specify total number of elements. Total number of elements in this place. If I want to have a memory space to hold 12 elements, integer type elements, then I give value 12. This will allocate a memory space which is capable of holding total 12 integers. Here this statement is going to be allocating the data items. For example, this is the memory space sufficient for one integer type. It would be essentially allocating memory space for total 12 items. 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think it's only 12. So I have total 12 memory space for 12 items. So this is actually one entire memory space. So entire memory space, but it is actually divided into the spaces for holding 12 integer items. So this is an array, dynamic array created by executing this, evaluating this expression, and the address to that array is actually copied to this pointer. Now coming back to the editor, you can copy data into, you can use regular array syntax afterwards to access the elements of the array. If we want to copy data into the first element, it's going to be 12, let me make it a bit smaller so that it gets easy for me to copy paste the things. So let me make it a smaller size so that it will be easy for me to just do it faster. So three, 18, 4, 21. So you can copy data into it, and it's also possible that you can use a loop to copy data into it if you have any way of producing data in the loop, writing into the loop. I'm gonna initialize this way now. Now you can use a loop to display the data. 5 I plus plus cout IARR PTR. So this should display the data. There is a pointer syntax. You can also use pointer syntax, but this is more convenient, right? So I will demonstrate pointer syntax in a moment. Let me compile this code and see the output. Now you can see the data printed 12, 13, 13, 18, 21, which was actually exactly the data that was set to the elements of the array. If you want to use pointer syntax, you can use like this. Let me just copy and paste. Let me just make change to this first element, right? So if you want to use a pointer syntax, just you dereference to access the first element, just dereference and copy. To access the second element, you add +1, and then within put everything within the parentheses and dereference. So this is a way of, this is a pointer syntax for accessing the elements 1, and for the second you will have I plus 2. For this case you will have I plus 3, and so on, right? In the case of for outputting, you can have the following syntax. Let me copy and paste and make changes to it. You can plus I and you dereference it afterwards, right? So this will actually do the same job, but this syntax is more convenient if you want, but it is worthwhile to be familiar with both syntax. I'm going to compile this code and show you the output. Now here you can see the output, same output displayed, right? But the only difference was the use of different ways of accessing the elements through the pointer. Coming back to IDE, now like before, you had to, when you created a dynamic memory, then you need to deallocate, right? In this case also you need to deallocate. So the way of deallocating here is kind of similar to this, but you just put the bracket over here, okay, because this is an array, right? So you allocate a memory by using this syntax. So you deallocate by having bracket in between this keyword and the name of the pointer, this way. So this is the syntax for deallocating memory. Now again, this is a dynamic memory. For a data item, and this is the dynamic memory allocation and deallocation for an array. Just remember this line, allocation, deallocation, and the way you can access the data. Now I am going to explain how dynamic memory allocation deallocation can happen inside a class. Right, so let me create a class called student, and the student has ID, and let me name it MID, and student has marks for different subjects. I'm going to put that marks in a pointer in a dynamic memory space, so double M marks. And if I have this array, I also need to keep track of how many elements are in the array, so int number, so number of marks. So this is the situation here. Remember, all these items are private by default in the class. Now I'm going to have some function to access this data from the public space, and I want to have a function to set the data. So void set function, and for setting the data, I need this function to receive the data to set into it. So first I want to receive ID, and I want to receive marks, and I'm going to receive number of marks, maybe size of the array, right? So this is the size of the array. Now I can directly copy MID ID to MID, now this is a pointer to the array. This is going to be a pointer array. For example, if I call this function from the main, client code or main function, I would have something like this: double marks 55.6, 66.7, 78.9, 98.2, to 88.4. These are the marks, and number of marks is going to be 5, right? So I would be passing this marks and the number of marks. So it will be a address. It's going to be the address that is going to be received here, and the size is going to be the 5 in this case, in that particular case. So ID directly copied. In this case, I want to store the array elements, and to store the array elements I need to create a dynamic memory space to be pointed by this pointer, right? So the size of the dynamic memory space is going to be this size, because we are going to pass total number of elements in this array as a third argument. Therefore I would allocate a dynamic memory to hold the marks, equals to new, the data type of marks is double, and now the size. And before that I also would like to copy size into n marks. If you have already copied, you can use the n marks here. Now once memory is allocated, then I want to copy in this memory space this data one by one. Okay, so the data is going to be received from this this parameter. So I will need to iterate for size number of times, then I copy, right? So now you have ID copied, size copied, total number of marks, and a dynamic memory space created, and the marks copied in that dynamic array, right? So now this is the function we can use to set the data into this object. Let me create a student object in the main function and then use this set function, right? So I want to create a student object, and I want to pass first ID. Let's suppose ID is 101 and marks followed by no marks, right? So looks like there is some issue here. It doesn't match argument list. Let me go back and see the signature of the function. Set or because we don't have this thing, so just I think that was a little bit I try to step ahead. So we'll come to that way of creating object. Now we create an object like this, and then you can use this object, and this is the member function of this class, so you can call the member function of a class through that object. So the way of calling member function is the name of the object followed by member access operator dot and set, and within the set function you pass those parameters, that the way I did before, 1001 and marks num marks, right? So with this we create an object and we set data into it, and that this data should be copied. But the problem here is I am not able to see what is actually written. I presume that this is set function correctly writes the data that was passed to it, but I cannot see, I cannot check, right? So to check it, I cannot directly access this data because this is private. I cannot access from here. So one crude approach would be, maybe you can display the data here in the set function itself. Just make sure that you use these variables, member variables, not this parameters, because we want to make sure that correct data is copied to the memory variables. So ID, then I would like to print marks afterwards. I need to use a loop for printing marks. I equals 0, I less than I plus plus. So this should display. It should copy and display what is actually copied in the in this video. So let me see. Let me test this function. Okay, I'm going to compile this code. Now you can see the output. The ID 1001 marks 55.6, CTC.7, 78.9, 98.2, 88.4. I think it is exactly copied. It is copied the way it is supposed to copy, but this is not a good way of I mean looking into what is copied, because you cannot use one function for the sake of cohesion of the function. You cannot use one function for multiple purposes. So I would like to have another function to display the data. And I could put everything in this logic inside the display function. So this display function should display the data, because this is a function which has access to the private members, so it should display. And for displaying, we will need to call that display function through this object, right? Let me one more time, let me compile this and show you the output. You can see the output, no difference, same. Now you can see this is the dynamic memory allocation for the class. You have to have one function that actually allocates memory and copies data into it, right? And also, how do you deallocate? For example, if you created this object and this set function internally allocates memory, right? In the previous discussion, I told you that if you allocate memory, you need to deallocate, otherwise you will have the problem of memory leak. So for each allocation, you have to have a deallocation. So display function, it doesn't have any way of releasing that memory, right? So you need to have a function that releases that memory. Okay, so for that purpose, I can use I can have another member function. You can give your own name. I'm giving a release, and inside the release function, I would like to have a statement that will deallocate memory that is pointed by this pointer, right? So the statement for deallocating is going to be the same as the statement for deleting an array. Okay, something like this. So you put that inside this release function. So this statement should release, but you need to make sure that you call this function, right? So at this point, if for example you create an object, you use this object, there could be some other things you want to use this object for. You want to set data again, then once you no longer need this object, the purpose of this object expires, then you call that function release, right? At this point, the memory will be released. And set will allocate dynamic memory. Now this explains the way you can have dynamic memory allocation for a class and dynamic memory deallocation for the class. And before that, we discussed dynamic memory allocation for one data item, dynamic memory allocation for an array, and corresponding deallocations. Now let me quickly uh, touch upon the memory issues, memory leak and insufficient memory. Okay. As I told you earlier, a situation where you fail to release the memory that is allocated is memory leak, right? So you need to be careful about identifying the situation where memory leak can happen. For example, if this statement is missing, then you should be able to identify that the memory is allocated for integer, but it is not deallocated. So there is memory leak. So you should be confident about that. Or memory for array is allocated in this way, but if deallocation happens this way, this is going to be the problem, because this will delete only first element, or it's going to run into some problems when you compile this code. So this is not a proper deallocation for the array. You need to have proper deallocation, proper syntax for deallocation. And if this release function is you fail to call this release function, then it will also allocate memory but will not deallocate. That will really result in the memory leak. And memory leak problem becomes especially problematic when you have a situation something like this. If this marks is number of marks is let's say 10,000, right? If number of marks is total number of marks in here is 10,000, in that case this function, this statement will allocate total amount of memory allocated by this expression is going to be 10,000 times the size of double, which is 8 byte, right? So it's going to 8,000 byte, 80,000 byte. This amount of memory, if you don't release by running this statement, and if you have other codes here, there could be some other code that will call another function, another class. There could be a lot of code coming up after this. For the execution of that code, this amount of memory will not be available. This is reserved, but you are not going to use that object anymore. This object you are not going to be anymore, but this object is still occupying the memory. And in some cases, for example, this object is within block scope. If you create this object within the scope, and this object comes into existence at this place, and it expires at this point, right? So if this object expires this point, then this object is not accessible anymore. For example, if I try to call that stu.release, this object is not accessible because its scope is within this curly brace. So at this point, once this object goes out of scope and you have not released the memory, then you have no way of accessing that memory. That memory will remain occupied, and the rest of the code will not be able to use that memory. That is the problem memory leak can cause. So you need to be careful about not having that sort of problem. So you need to be skillful. You need to develop your skill to detect, to identify, and to correct the problems, the code that can potentially cause memory leak or that is causing memory leak. Okay. Now let us quickly focus on insufficient memory problem. When we have a big computer, most of the computer, they have a lot of memory these days, but we are also carrying small devices, and in many cases where people are using sensors. For example, ECG, if you are familiar with this, to body. ECG sensors attached to the body. You might have seen some patches ECG patches attached to the body, or some of you might have used that. Those sensors, they have very limited amount of memory. So if you need a software to run in this kind of devices, and these devices frequently run into the problem of insufficient memory, right? And this memory leak issue becomes even more problematic in this situation, because even a small amount of memory is very, very, worthy, very, very precious. So these are the challenges we need to be careful about. If you are working in very small devices, you need to be also mindful about the potential problem of insufficient memory. Okay, with this I end this this discussion of the topics.